Alright, so here we have 60 kilograms of aluminum at 15 degrees Celsius, and it's placed into 20 kilograms of 90-degree water. Find the final temperature of the two. Alright, so we know that we have two objects that are being placed. The aluminum is being placed in the water, and eventually they are going to reach thermal equilibrium and have the same final temperature. So we know we are dealing with this equation right here, so we'll go ahead and write that. Alright, 0 equals Q hot plus Q cold. Now we need to figure out what is Q hot and what is Q cold. So 0 equals, alright, Q hot is the one that was going to be hotter originally and is going to be losing heat. Okay, well the aluminum was only 15 degrees Celsius. The water is 90. We know that we're going to get a temperature somewhere between 15 and 90, but that water was pretty hot to begin with. It was actually the hot material. Okay, so we know that this is the water and that the cold was actually the aluminum. So we're going to go in, and every time we see a Q, we're going to use the heat equation for heat transfer during a temperature change. So mass times specific heat times change in temperature plus mass times specific heat for that item times the change in temperature. Alright, so now we start plugging stuff in. The mass of the water was 20 kilograms. The specific heat of water is actually very high. It's 4,186. And the best we can do right now for change of temperature, we know it's always final minus initial. The final we do not know. We are trying to solve for that. But the initial was 90 degrees. Alright. And we know that the water is going to be cooling down. So this is going to be a smaller number, which is going to cause this to be negative. Alright, which makes sense. It was the hot item. It will be losing heat. Alright, next we have the aluminum. The mass of aluminum was 60. Alright, now we need the specific heat of aluminum. So we're going to go over to the chart. It is 899. Alright, and just like for the water, we do not know the final temperature, but we know the initial was 15 degrees Celsius. Okay, so our next step would be to multiply the first set of numbers out. Alright, so 20 times the specific heat of water, 4186, is equal to 83,720. And remember, that's still being multiplied to the final temperature minus the initial temperature of 90. And this is also added to. We're going to simplify this by taking 60 and multiplying it by 899. And we get 53,940. And that is still times the final temperature minus the initial temperature of 15. Alright, the next step is probably the trickiest, but if you just stick to the process, you'll be perfectly fine. What you're going to do for both of these, both the hot and the cold, you have to take this first number and distribute it to both items inside of those parentheses. So for instance, 83,720 times the final temperature is going to look like this. 83,720 TF. Alright, Now we know the next number is going to be minus, because this is a negative 90. And we're going to multiply 83,720 by 90, or negative 90, but we already know this is going to be negative here. So it looks like 7,534,800. Alright. Plus, and we're going to distribute this 53,940 times final temperature is just going to say 53,940 TF. Alright, here you can also go about it this way. In the last section I just multiplied this by 90, but you could say 53,940 times negative 15, and that's what you'll be writing, is what it gives you there. So 53,940 times negative 15, or minus 15. So you'll get minus 809,100. Alright, so what you can do now, and I'm just going to go to I'm going to use purple now. I'm just going to add everything up. Anything that has a final temperature on it cannot be mixed with just a number that's on its own. But we could add this 83,720T to this 53,940T. So that's what we're going to do. 83,720 plus 53,940. And we get 137,660. And of course that's being multiplied to the final temperature, T sub F. Alright, now we have these two other numbers left, this minus 7 million and this minus 809,000. Alright, so we are going to add those two together. Keep in mind these have negatives in front of them, so it is a negative 7,534,800 plus a negative 809,100. Now if you do not include those negatives, then it will take your total and get it completely off. So it is important, if that has a negative sign in front of it, you need to apply that whenever you are adding these numbers together. So we end up with plus, but it's technically you can say minus this much or plus a negative 8,343,900. Alright, so now what you can do, you have this number that's negative on this side. You could add negative 8,343,900 to both sides. So then you will get a positive 8,343,900. And that will be equal to 137,660 times the final temperature of both items, since they are in thermal equilibrium. So now if you want to solve for the final temperature, the last thing that you need to do is you can divide both sides by this 137,660, and that will get your final temperature on its own. Alright, of course on this right side these cancel out. Alright, so 8,343,900 divided by 137,660, and we get 60.61 degrees. So our final temperature is 60.61 degrees Celsius. Alright, so let's think about this. We know we were going to get a number between 15 degrees Celsius and 90 degrees Celsius, and we did. Also, we know that if you look at water, it has a much higher specific heat than aluminum, all right, over 4 times as much. So that water is going to resist the temperature change more than the aluminum will. So we should get a temperature that is closer to 90 than to 15. Now notice that 60.61 is less than 30 degrees off from the original 90 degrees of the water. But 60 and 15 have a much bigger difference. How about a 45-degree difference there? Alright, so that's bigger. Okay, so we have found the right answer and we are done.